Alright, so for question 2, part A asks that we show that y equals 1 over x times the integral of f of x dx as a solution to the differential equation x dy dx plus y equals f of x, where x is greater than 0. This is going to be pretty straightforward. What we have here is the result of taking the derivative of two multiplied factors. So if we take the antiderivative or the integral, we'll end up with those two factors multiplied together again. What we have here is the multiplied factors of x and y, as seen with x in the derivative of y in terms of x, plus y times 1, which is the derivative of x, equal to f of x. So when we integrate both sides, we're going to return to that xy, which is what would happen before you take the derivative and take the multiplication rule into effect, equals the integral of f of x dx. Thus, we have satisfied the condition and solved part A of this problem. Moving on to part B, hence, solve x dy dx plus y equals x to the negative 1/2, where x is greater than 0, given that y equals 2 when x equals 4. We're going to have to pay very close attention to that word hence, which is IB slang for do it the way we just told you to do it in the part before. In part A, we had a formula where x dy dx plus y equaled f of x. In this case, we have a very similar formula. However, instead of f of x, we have x to the negative 1/2. So, when we define f of x from part A as x equals negative 1/2, we can just use the solution that we found in part A and plug in x equals negative 1/2 for f of x. Therefore, we have y equals 1 over x times the integral of x to the negative 1/2 dx. When we take the integral of x to the negative 1/2 dx, we get 2x to the 1/2 plus c. Now we're going to plug in the point 4, 2 as listed in part B of the problem. This will give us 2 equals 1 over 4 times the quantity of 2 times the square root of 4 plus c. Multiplying both sides by 4, you get 8 equals 4 plus c, 4 being product of 2 times the square root of 4, of course. And subtracting 4 from both sides, we get that c is equal to 4. Therefore, when we plug c back into the original equation, we get y equals 1 over x times the quantity of 2 times the square root of x plus 4. And therefore, we have gotten our answer using our process from the part before.